Okay, in lesson 17, we looked at one-step equations with addition and subtraction. Today, with lesson 18, we're looking at one-step equations with multiplication and division. We're going to use similar ideas to the beginning of the unit when we saw the relationship between multiplication and division. So for example, in this first problem, it says 3 times z, remember 3z means 3 times z, is equal to 9. The goal here, once again, is to get the variable by itself so we can determine what z is equal to. I know most of us can probably realize what it is right now, but we want to do it in an algebraic fashion. So, if you recall, if we did z times 3 and then divided it by 3, we wound up back at z again. So that's just a little refresher from the beginning of the unit. So we took a variable, multiplied it by a number, and then divided it by the same number and got back to the variable again. Well, we're going to do that same thing here. To show division in an equation, we use the fraction bar. So if I want to divide this by 3, since I'm multiplying by 3, I would draw a line underneath it and then put the 3 down. If you think about it, 3 divided by 3 is 1, and 1 times z is just z. So these two then cancel each other out, leaving us with the variable, which is our goal here. We want to get the variable by itself to see what it's equal to. Since we divided the left side of the equal sign by 3, we have to divide the right side of the equal sign by 3. We're going to pull down our equal sign and do 9 divided by 3, which is 3. For our check, I'm going to start by expanding the problem. Still the same problem we started with, just expanded. I'm going to replace my variable with what I'm saying it's equal to. And then since 3 times 3 is a basic fact, I wouldn't expect you to show side work for that. And 3 times 3 is in fact equal to 9. So same process as yesterday, using the inverse operation to both sides in order to solve for the variable. So for the next one, we have 13 times v is equal to 117. Again, my goal is to get the variable by itself. So if I'm using multiplication, I'll want to undo it with division. So I'll divide both sides by the number that's next to the variable. So divide by 13. 13 divided by 13 is 1, so they just cancel each other out, leaving me with v. And then I would have to do 117 divided by 13. Okay, so 117 divided by 13 is 9. So if I pull to the side just to prove, it does in fact work out. Okay, so I would get 9 here. For my check, again, I'm going to start by expanding this, replacing, and then I've actually already shown my side work right here that proves 13 times 9 is 117. Okay, so here's some more examples. Now we're bringing a fraction in. So in this problem, it's 1/2 times y. So I'm just going to divide by 1/2. Divide by 1/2. I know it looks kind of funny when there's a fraction in a fraction, but it's absolutely fine to have that. So these two cancel each other out, leaving us with y. I'm going to do 6 divided by 1/2. I'm going to rewrite this as 6 over 1, and I'm going to, instead of dividing by 1/2, multiply by the reciprocal of 1/2, which is 2 over 1. 1 times 1 is just 1, 6 times 2 is 12, 12 over 1 is the same thing as 12. Okay, so over here, I'm going to start by expanding, replace the y with what I'm saying it's equal to. When I do my side work here to show it, I'm going to put 12 over 1. I'm going to do some cross simplifying. 2 and 12 can both be divided by 2. And I wind up with 6 over 1, which is in fact the same thing as 6. Okay, so now we just have a decimal. I'm going to do, it's a multiplication problem. I have 2.3 times x. So that means I'm going to divide by the number that's next to the variable, so 2.3. I'm going to do this to both sides of my equation. These 2.3's cancel each other out, leaving me with x, and then I have to do some math. So I'm doing 20.7 divided by 2.3. Just a reminder that we don't actually divide by the decimal. We're going to move the decimal point to the end to make it a whole number. Since I moved it over one place, I'm going to move the decimal in my dividend over one place as well, changing this into 207 divided by 23. Now, I see that this ends in 3 and this ends in 7, so I'm going to start with 9. Just because I know 3 times 9 is 27, which ends in a 7. And then I see that it actually works out. So I get x is equal to 9. For my check, I'm going to start by expanding it. Now, I'm going to show my multiplication here. It's 2.3 times 9. It's going to be the same exact math as what you see up here. The difference is that there's a decimal. So I have a decimal, one decimal here, none here. So altogether I should have 1 after the decimal in my answer. And 20.7 is in fact equal to 20.7. Okay, so now that we've seen what multiplication equations look like, we're going to see what some division equations look like. You're going to see division written in a couple of different ways. You may see it as the fraction, or you could also see it written like this. When we see this, this is the same idea, like if I had y divided by 4 and multiplied by 4, I wound up back at y again. That's again from one of those first lessons in this unit. So what that's saying is if I take y divided by 4 and multiply it by 4, I'll wind up with that y again, which is my goal, to get the variable by itself. So I'm going to multiply by 4. The way I'm going to show it is a little different here. Since this is written as a fraction, I'm going to write 4 as the fraction 4 over 1 to the side. These cancel each other out, leaving me with y. I'm also going to show my multiplication to the side over here, just to make it a little cleaner where I don't have some to the side and some underneath. Then I'm going to do 2 times 4 to get what y is equal to. So with division, this is where we're going to show the inverse operation on the side of the equation instead of under it. For my check, I'll rewrite the original, and you have to be careful here that you're not including that times 4 on either of the sides, because that's not in the original equation. I'm going to replace the y with 8. This is saying 8 divided by 4, so 8 divided by 4 is 2. It's a basic fact, so I wouldn't expect side work. And that does, in fact, check out. For the next one, I have x divided by 16. So in order to get x by itself, I would want to multiply by 16. You don't have to include the over 1. You can just write times 16, getting your x. And then over here, I would do the same, times 16. I'm going to pull to the side to do my multiplication. Don't forget your place saver 0. Add together to get your answer. Okay, so for my check, again, I'm going to rewrite the original equation, not putting that times 16 on the side. Replace the x with what I'm saying it's equal to. And what I should do is I should use what it's saying it's equal to as a guide. So 240 divided by 16. So my first number should be 1. So 16 goes into 24 one time. That is correct. Okay, it is less. It's good to go. Pull down the 0. 16 should go into 80 5 times. Pull to the side to double check. And it is, in fact, workable. So we get the 15 here, balancing to the 15 here. It checks. Okay, so now the next one is a little different. In this case, the variable is in your denominator. So what you're going to do here is you're going to multiply both sides by the variable, which is going to rewrite this as a multiplication equation. These b's will cancel each other out, leaving us with 165. And now I can't do 11 times b. I don't know what b is equal to. So what this does is it turns it into 11b, and it's now rewritten this division equation as a multiplication equation. So now I'm going to actually use division to solve it. So I'm going to, since 11 is next to the variable, that means it's being multiplied, I'm going to divide both sides by 11. These 11s will cancel out, leaving me with my variable, and then I'll divide this. I know my tricks for 11, but I will still divide anyway to show that it is in fact equal to 15. For the check, again, rewrite the original equation, replace the variable with what you're saying it's equal to. And in this case, we actually already have, we don't have our work, but it's kind of the same thing, but we're going to actually divide by the 15 to prove that we didn't make a mistake over here. And it does give us that 11. So if your denominator, or what you're dividing by, is the variable, it's actually going to have you rewrite the equation. So be careful of where the variable is with these. In the next one, we do have a decimal. The variable's in our numerator, so this is okay. We're going to multiply by 2.5 on both sides. These two will cancel each other out, leaving us with our variable. We're going to have to do some math here. Again, you can use your calculator. Don't forget place saver zeros if you don't. And this is a great way to practice because you'll be checking your answer. So here there's 2 digits after the decimal. There's 1. So altogether there should be 3 after the decimal in my answer. Okay, so now let's see if I made any mistakes in my multiplication. So I will do the original. I'll replace. I'll show my work to the side. So this is 33.625 divided by 2.5. Remember, we're just going to move the decimal to the end here, which was 1 place. So we'll move it 1 place here. Okay, since there's a decimal here, we're going to pull it straight up. This should be my guide. Okay, so I should be getting 14.25, so I can use that as my guide. 25 does go into 33 one time. There's my 1. Pull down the 6. It should go in 4 times, which, it doesn't. I must have a mistake somewhere. So now I have to figure out where my mistake is. Okay, so after relooking my work, I see what I did wrong. I did 33 instead of 35. So this is how we catch our mistakes. It's okay to make mistakes. This is why we should always go back and check our work. So I'm just now replacing all of my 33 with 35. Okay, so now that it goes in, subtract 25 from there, we get 10. There's our 106. So now 25 does go in. We get 100. I'm going to run out of space here. 25 would go in twice, which is 50. So I'm just going to have to cheat and pull over here. That leaves me with 12. I'd have to bring down that 5, and it does, in fact, work out. So see, it's good that I made that mistake because we can all see that we have to be careful in how we're showing our work. Okay, so now we're going to write multiplication and division equations. So this one says Carlos is trying to read 12 pages of his book a night. The book has 156 pages. How many days will it take him to finish the book? Let n equal the number of nights that Carlos reads. So the equation here is going to be 12 pages per night. So that's saying 12 times the number of nights would be equal to the number of pages he's read, which is the 156. So one thing that you could do here, if you weren't sure of what your equation would look like, is to make a table. We've done this. So we've got pages and then total. Oh, I'm sorry, this should be days. Or nights, actually, for N, nights. I guess I should stay with what it has. So if it's night 1 and he's reading 12 pages per night, that means a total of 12 pages. So to get from 1 to 12, we multiplied by 12. Or we took our nights, multiplied by 12 to get our pages. And in this case, we know the number of pages for this certain time, so it would replace T for total, or however they would want you to write it. So you can use a table, just like we have with our ratio tables. So to solve this, since we're multiplying, we're going to use division, and we're going to divide both sides by the number that's next to the variable. So we'll divide both sides by 12. These 12s cancel each other out, leaving me with my variable. I'll need to divide here. And I get 13. It's important to show a check. Rewrite the original. I'm going to expand it. I'm going to pull to the side to show my work. And it does, in fact, work out. Okay, so that's how we would do a multiplication equation. Okay, the next one says, at a restaurant, Mike and his 3 friends decided to divide the bill evenly. If each person paid $13, then what was the total bill? So first of all, we have Mike and his 3 friends. That's 4 people. Don't forget to include him. We're looking to find what the total bill was. So to figure out what the total bill is, we would need to know the total. We are taking that total and dividing it by the 4 people, and that would tell us how much each person is paying. In this case, it's telling us each person paid 13, so that would be equal to 13. So now, when I go to solve it, I'm going to write it like this. I'm using division here, so I'm going to multiply both sides by the 4. These will cancel each other out. And I'll do 13 times 4, which if you're a card player, hopefully you know, is 52. So now when we go to check, we have the total divided by 4 equaling 13. 52 divided by 4 should equal 13. Prove the work. And it does, in fact, balance out. Okay, so for multiplication and division, you use the inverse operation to solve. Just be careful with division equations. Make sure that the variable's in the numerator. Otherwise, you're going to have to multiply both sides by the variable and redo it as a multiplication equation. And also make sure you're showing that multiplication to the side, just to keep it nice and neat.